I'm again working the review problems. I know the answers are on the back, but just in case you have some questions, the first three ask about the domain of the rational function. And you can go back to the video from the homework that has problems 2 through 8 on it and look at the rules for how do you find domain of a function. Basically, it's the domain is going to be all real numbers unless you have a variable in the denominator like we do here in number 1, or you have an even root. So the rule is if there's a variable in the denominator, x can't be anything that would make the denominator equal 0. So in this case, x can't be 0. And the way that we write that in interval notation is we say, because what that's going to look like on a number line is it means x can be all this, can't be 0, and then it can be all this. So what we say is that it's from negative infinity to 0, and then from 0 to infinity. Problem number 2. I have g of x equals x minus 2 over x plus 3. The numerator can be 0, so I'm not concerned at all with the x minus 2 on the top. What I am concerned with is the x plus 3 on the bottom. It can't be 0. So what I want to do is I figure out what value of x would make it 0. If x is negative 3 and I were to plug it in here, I'd have negative 3 plus 3, which would make this denominator 0. So x can't be negative 3. And the way that I write that is I say it's from negative infinity to negative 3, and then from negative 3 to infinity. Because that, again, on a number line means that x can be everything here, can be everything here. It just can't be negative 3. So from negative infinity to negative 3, and then from negative 3 to infinity. And problem number 3, on the top, I have x minus 4 and x plus 2. And on the bottom, I have x squared minus 1, which if I factor is x plus 1, x minus 1. So looking here at the bottom of this fraction, x can't be negative 1 and it can't be 1. So on a number line, what that looks like is it can be all of this stuff, it can be all of this, it can be all of this. It just can't be negative 1 and can't be 1. So I write that from negative infinity to negative 1, from negative 1 to 1, and from 1 to infinity. And that's how you write that. All right, number 4, they want me to express this in simplest or lowest terms. On the top, I have 21m to the 6p squared, and on the bottom, I have 3m to the 9th p. So you want to look for a common factor between 3 and 21, which is 3. 3 goes into 3 one time and into 21 7 times. I have m to the 6th and m to the 9th, so if I were to take 6 m's away, it would leave me with m to the 3rd on the bottom, and I have a p squared and a p. So if I were to take a p away, I'd have a p still left on the top. So the top's going to be 7p, and the bottom's going to be 1m cubed. So 7p over m cubed, which is b. Number 5. Number 5, I've got y plus 2 times y minus 5 over y minus 5 times y plus 6. You can cancel the y minus 5's, and that's your answer. You cannot cancel the y's here, or the 2 and the 6, because they are terms, not factors. If there's a plus or a minus in between, you have to take the whole factor. You can't just take part of it. So y plus 2 over y plus 6, my answer is B. Number 6. Top is a squared minus 9a, which if you factor it, some people thought it was a difference of squares, but it's not. It has a GCF, which is a. If I take an a out, I have an a minus 9. And the bottom is a plus 4, a minus 9. And so I can cancel the a minus 9s, and my answer ends up being a over a plus 4. And so that answer is A. Number 7. On the top I have 3x plus 2, which doesn't factor. On the bottom I have 12x squared plus 23x plus 10, which does factor. If you don't know how to factor this, the easiest way is to multiply the first and the last together, and that gives me 120x squared. So I'm looking for two numbers that when multiplied together give me 120x squared and that add up to 23x. So like 10x and 12x would multiply, but that wouldn't add up to 23. but 8x and 15x would multiply to give me 120x squared and would add to 23x. And so then what I do is I replace 23x with 8x and 15x. And I'm going to factor by grouping. Out of the first two, I can take out a 4x, and that leaves me with 3x plus 2. Now the last two I can take out a 5, and that leaves me with a 3x plus 2. So my common factor is 3x plus 2, and my other factor is 4x plus 5. This should be a 2, not a 12. I'm like, where did that 12 come from? It's 3x plus 2. I wrote it down wrong. So my factors are 3x plus 2 and 4x plus 5 on the bottom. So the 3x plus 2's can cancel. I'm going to put a 1 to hold the place. So the top is a 1, the bottom is 4x plus 5. So my answer is B. Okay, we'll stop this video and I'll pick up on number 8.